In this tutorial, we're going to look at plotting some X-ray powder diffraction data that was loaded into R in the previous tutorial. And if you haven't already done that, you'll need to, because we're going to be working with that data, and the examples won't work without having done that. So if you haven't done so already, you'll also need to load the PowerDAR package into your R session. So we've got a few different pieces of data loaded into our environment. We've got XY1, XY2, and XY list 1 and XY list 2. So these have various plotting methods associated with them. So if you have a look at plot.xy, we'll see that we have a plotting method for XY objects, such as XY1. You can see if you hover over it, it's an XY object, and you can see the various arguments that are accepted for plotting these objects. Similarly, we've got multi-XY objects here, so we can have a look at plot.multi-XY, and we get similar information, this time for multi-XY objects. Again, it's from the PowerDAR package and all the arguments that are accepted for plotting those. So we're going to just create a pretty basic plot by using this line of code at the top. And setting interactive to false will mean that the plot that gets loaded is simply a static ggplot2 plot. You can't zoom in and look at the minor features. If we set interactivity to true instead, what loads is an interactive plot object, which is really useful because you can actually zoom into the minor features of the data and also get information on the despacing, which is why you have to define the wavelength, because it will calculate the despacing based on the 2 theta in combination with the wavelength used, which in this case is a cobalt X-ray source. So that can be really useful using interactive plots whenever you can. So that's just for a single diffractogram. We can use a similar form of code to plot a multi-XY object instead. So we'll plot XY list 1 using this line of code here. And when this loads, we should have 5 diffractograms plotted interactively against one another, or aside one another. So these are 5 different diffractograms, and we can see those differences. So then they're all labeled quite nicely as it's an interactive plot. There are additional arguments for these plotting methods that you can get help for. One of those is xlim and another is normalize. And you can use that to kind of isolate specific regions of the diffraction data. So if we plot XY list 1 again, but only focus on 30 to 32 degrees 2 theta and normalize it, so the peak intensities are the same or scale to the same maximum, what we end up with is a plot that focuses on the main peak in the data with the maximum scaled to 1. So all of these plots that are derived using the plotting method for XY and multi-XY objects, they're created behind the scenes using a package called ggplot2, and that allows you to build up plots in layers. So if you kind of treat these basic plots that we've just done as like the basic layer, you can actually adapt and add to them, which can be quite useful. So if we take an example where you want to, identify the quartz peaks on the data, you can extract relative intensity information from like a mineral database. So I'll just create such data for quartz here. I'm just creating a data frame of 2 theta locations of the peaks along with their relative intensities. And then if I load the ggplot2 package, we can begin to build up a plot. So what we're going to do here is plot xy1 using the same parameters we had above. So if I just use that line, we can end up with the same plot that we had earlier, but the counts are now normalized to a maximum of 1. And in ggplot2, what we're going to do is add this plus symbol and create another layer which will be added to the plot. So we're going to add a points to the data, so g on point. The data we're going to use is this quartz data frame, which you can look at here. It's a pretty simple table of points. And what we want in this AES wrapper is the x-axis to be the 2 theta and the y-axis to be intensity, defined in those column names. And we're going to change define the size and shape of the files as well, of the points as well. So if we highlight those first 2 layers and run that, you can see how all of the peaks are now identified. You can continue to add layers such as the title quite simply. And even if you wanted to, you can add various themes to the plot as well to change the default backgrounds and grid lines, etc. So that's just touching the surface of what you can do to modify plots. And in addition, what can be quite useful is if you send all that code to an object. So we'll create P1 in our global environment, which you can then load simply by running P1. In addition, what you can do if you're using ggplot2 is you can make almost any ggplot2 object interactive. And to do that, you just have to load the plotly package, which you will have installed on your computer if you've installed Powdar, because it's a requirement of installing Powdar. So now if we just wrap P1 in this ggplotly function, it will load that graph, but in an interactive form. So you can now zoom in on it and you can get various information on the data that is plotted within the graph. So that's really useful because pretty much any ggplot2 graph can be made to be interactive using that approach. So that's like a couple of basic plotting functions for XY objects and multi-XY objects of X-ray powder diffraction data. There are more methods that will be introduced later on in the course associated with different types of objects as well. But ultimately, it creates a basic plot which you can kind of add to with the various additional functionalities of ggplot2.